Hello, my name is Deborah Betzer. This is the DP3 presentation for Team 3. So in this presentation, I'm going to be going over the design process that happened through the duration of our project. I'll be talking about some previously mentioned topics as well as some new topics such as the failure mode effect analysis, the design for assembly, design for manufacturing, the bill of materials, and the CAD models and prototyping. So as a recap, this is our mission statement. So when creating our mission statement, our main focus was to have a pin that was both functional but also had a fidgeting device attached to it. And the main reason we wanted to do this is because our primary target is the VT student body. The reason we kind of wanted to do this is because some students sometimes have a hard time focusing while taking notes. And we thought having a fidgeting device attached to the pin would help them be able to take better notes and focus in class a little better. So these are our customer needs. We kind of have a wide variety of them, but they kind of mainly categorize into four separate functions. These being ergonomics, functionality, mechanics, and customization. They're kind of self-explanatory, but the ergonomics is how how the pen feels in your hand when you're writing. Functionality is how well it writes. Mechanics is if the bolt action mechanic to actuate the pen works, and then customization is the ability for the customer to customize particular parts of it. With that being said, when designing our pin, we had some specifications that we decided to design our pin by. It was kind of difficult to create some specifications, but we kind of used the QFD. So with that being said, our first specification was spring stiffness. Second one was how long the ink will last. The third is the number of cycles the bolt action mechanic will be able to use for. Total production cost. The size of the pin in length and width, and then the comfort of pin, which we chose to do in weight. Okay. So this is our functional decomposition chart. So basically it serves as a visual representation to show what our product does. Unfortunately, since our product is just a pin, it doesn't really have that many functions. To start it off, basically our pin has to have a user input, and this user input is made into the bolt action mechanic that is used to fidget with. Now this can be either turned on or off by fidgeting with it, but if it is left on in the on position, then the pin can be used for writing. So when making designs for our pin, we used our concept concept combination table. Basically, this has three sub-function categories under fidgetry, ergonomics, and assembly. And basically, in these three categories, they have different types of features that we could use. And then these features are then combined in order to make designs. So you can see at the bottom, there's 3 pictures, and these are actually some of the examples of the designs we did. Also on the combination table, you can see if you follow the arrows, we actually had a total of 6 different combinations that we used. And then from these combinations, we actually decided to make our pin from one of these combinations. So this is our failure mode and effect analysis chart. So as a team, we took each of the item or parts of our pin. So that would be the bolt action mechanism, the mechanism attachment or the nub, the shaft of the pen, and then the pen tip. We took these parts and then we determined what type of failure mode they would have. And when doing this, we kind of figured out the effect of the failure, the cause of the failure, and then the detection method that we have. And then by taking all of these three things, then we were able to quantitatively figure out the severity, occurrence, and detection into a number form. And then by doing this, we were able to multiply these numbers into an RPN. So by doing this and figuring out our RPN, we were able to figure out which piece of the pen was at the highest risk for failure mode. And it happened to be the pen tip, which is very interesting because when creating our prototype, our pen tip was the part to fail the most. So this is our design for assembly table. So as you can see, it's a little difficult to read, but basically what we did was we used the Boothroyd and Dewhurst tables to calculate the row, and use the row and column of those tables to calculate the time it would take to assemble each of the parts of our pin. So after our actual design process, we had 6 parts of the pin plus 2 parts that we weren't creating, so 8 parts total. But when we went to assemble the pin, we have 11 operations. So as you can see, we have to orient a lot of the pieces and then attach the pieces by however they are dictated when we were designing the piece. So there are 2 different charts that we use. We use the handling chart and the insertion chart. So as you can see, for operation 1, for example, we have to orientate part 1, which was the pin head. So we used the handling chart, which was a 1-1, and that took 1.8 seconds. And then we did this for every single operation we had. And we used either table that was necessary. So for a lot of them where we're oriented, we're using the handling. Where we're actually attaching and combining parts together, we would use the insertion table. So for example, on operation 5, where we're inserting P3 and P2 into each other, we use the insertion table, which is a 2-2, and that gave us 6.5 seconds. In total, the total assembly time was 41.69 seconds, roughly 42 seconds. And this equated to 86 units per hour. At 86 units per hour, at a $15 an hour wage, that would roughly cost 17 cents per item. So this is our bill of materials. So as I stated before, we do have 8 parts, with part 7 and part 8 being the ink cartridge and pen spray. This costs roughly $1, and these parts will be bought separately. So we're mainly looking at parts 1 through part 6. These parts are the pen head, the shaft, the bolt carrier nub, the pen clip, and the pen cap. These parts are made out of PLA plastic, and needing about 20 grams of plastic, these parts roughly equal about 60 cents of material. Now, at the $1.60 margin, we do not include the assembly cost of 17 cents in that, but we would look at that future when looking at large-scale manufacturing. So these are our CAD models. So from our design to our actual CAD models, we did make a couple modifications. The main one being we went from a cylindrical to a hexagonal shape. The main reason we did this was for ergonomic sake as well as ease of printing. The other main difference we had was the clip attachment that we had to the back of the pin. And this was done basically to be able to attach the pin to notebooks or your clothes or your pockets and so on and so forth. So this ended up being our final prototype. As you can see, it is very similar to the CAD model. And the greatest thing about this is all the pieces fit together very well, and we do have the tolerance to be able to actually use the bolt action mechanism. As I said before, we did have one issue with the tip failing to print, so we were unable to actually screw it in, so we did have to press fit it in. That was the only downside, and we will look to fix that in the future. But the main functionality of the pen works properly, and you are able to write with it. So as you can see, we have come a long way from our original design at the beginning of the year to our final prototype at the end of the year. However, there are a couple improvements that we'd love to make in the future. One of these being printing the tip and the shaft together at the same time, since there was that failure point between the tip and the shaft, which did not allow us to have a spring inside the pin. Another being the nub, which was very, very brittle. We would love to strengthen that to be actually able to use it properly. And then another improvement we'd love to make is also moving the cutout for the bolt mechanism further up on the pin in order to increase the ergonomics or holding area of the pin. Overall, this shows the design processes that we took for designing our bolt action pen. Thank you very much.